Hi guys, welcome to another episode of MrLopezClasses.com. This is our gasoline engines course, and this is the chapter 3, ignition systems, and today this is the episode number 2. We are going to talk about the ignition system in outboards. Yes, outboards 4 strokes and 2 strokes. Okay, my friends, don't forget that in 4 strokes, you remember in the previous episode, ignition system for inboard 4-stroke engines. The ignition system depends of the timing position. This is one of the factors. Depend of the injection of the fuel in the combustion chamber, and depend of the spark in gasoline engines. The timing position, the injection of the fuel, and the spark, in what moment the spark is produced. Alright, the majority of the engines, the new engines today, the spark and the injection of the fuel is controlled by the computer. The computer, according with the position of the piston or position of the crankshaft and camshaft, with that information, the computer said to the injector, open the injector, spray fuel, and say to the coil, send the current to the spark plug, and the spark plug produce the spark. This is the computer, and the computer receives the signal from camshaft position sensor, crankshaft position sensor, and other sensors, throttle body and oxygen sensor. But crank and cam are the most important. This is in 4-stroke engines. Remember, in outboards we have 4-stroke engines and 2-stroke engines. In 4-stroke engines, it's exactly the same like inboard 4 strokes. Exactly the same. You need calibrate, piston number 1 in top the center, the timing of the crankshaft, the mark on the gear of the crankshaft aligned with the mark on the gear of the camshaft, and the timing chain connected between both of them. Exactly the same like inboards. For outboard 4 strokes. For outboard 2 strokes, you don't have camshaft. Yes, because you don't have valves. Remember? The fuel, the oil, and the air enter mixed in the crankcase, because the intake manifold is located in the crankcase. Those 3 elements enter in the crankcase, lubricate the bearings of the crankshaft, and enter in the combustion chamber when the piston suction that mixture. This is in 2 strokes. What happened in the combustion chamber? The piston compressed that mixture, oil, air, and fuel, and used before, because normally it's before, you remember? Advanced, before the piston reached top the center, the spark plug produced the spark. Yes. In 2-stroke engines, the computer only needs control in what moment the injector open, spray the fuel, and in what moment the spark plug produce the spark. That situation is controlled by the computer. For that reason, I explained to you before in the previous episode the relationship in between the coil with the spark plug and the injector.
So in this case, they call it the indexing. So if you look here in the line, you make a line for the open electrode. Okay. So when you install this, you have to install it either, you can be 90 degrees or 90 degrees the other way, 180 degrees.
The opening in front.
Yes. If you do it this way, what happens is the spray pattern is disrupted, and what happens is it will work, but it'll foul out the plug.
Oh, incredible. And what is the symptom? Misfiring.
Misfiring.
Oh, nice. It's only because the position of the spark plug is not appropriated in front of the injector. Normally, it's like this, no? In the combustion chamber.
Correct. Yeah, you want it facing
like this. That's perfect.
The open electrode.
Oh, incredible. In some engines like the E-Tech, you remember that video, the spark plug should be in front of the injector in order to improve the performance of the engine. That's very, very important. Yes, my friend, this is in two-stroke engines. In two-stroke engine, you need control, basically, if the engine is direct fuel injection, you need control the moment of the injection of the fuel, and you need control the moment of the spark. Both of them are controlled by the computer. For that reason, it's important the relation in between the computer and the coils with the spark plug.
Danny, it's a special relation in between the computer, the coils, and the spark plugs. In this particular engine, in this particular example, is critical, no?
Absolutely. It has to know what cylinder fire at what position the engine's in. So this one has actually a countercoil, which actually counts the teeth on the flywheel to know what position the engine, if it's at dead top center or is it number 2, and the computer takes that information, reads it, and transfers the power to the coil and then to the plugs.
Okay, can I replace the coils individually?
Yes, you can.
All right, and of course the spark plugs and the cables.
Correct.
All right. When you order the kit is coming computer and coils together?
No, you would add that everything on this would be actually ordered a la carte.
All right. Okay. Is frequently damaged the computer?
The only way the computer gets damaged is backgrounds, overheat.
Overheat. That's the enemy, no?
That's it. The two things that will damage the computer.
Alright, this is the situation in between the computer and the spark plug. But other important thing is the protection of the harness, because in those engines the injection system depends on the computer and the signals. For that reason, the ground is critical. The ground should be good ground. What is the ground? The ground is the connection of the harness with the block of the engine, and the block of the engine properly connected with the sinks located in the lower unit, in contact with the water. Remember, my friends, in our previous classes, the ground in your boat is the sink. And that piece of sink, in this particular case, located in the lower unit, is the ground of your boat. Of course, because that piece of sink is in contact with the water and the water in contact with the salt. For that reason, the ground is important and the harness should be properly protected. The fuses are critical. Why the fuses are critical? For what reason, Mr. Rodriguez, the fuses are critical?
Danny, in about 99% of the fires start for an electrical issue.
Yes.
And normally in engines, specifically in outboards and inboards, the protection of the harness is critical.
Very critical.
What happens in this type of engines if the people take a decision, I'm going to replace that fuse 10 amps for other 40 amps?
Well, what happens is, if the fuse is blowing, there's a reason why it's blowing. You have to figure out what the problem is.
Yeah.
So
right.
obviously this is a fuse panel here, and we'll take it off real quick.
Okay.
And there's your fuse panel, okay? So if you took this 10 amp and put a 20 amp, if you look at the picture above, that's your result.
This is the consequence.
And that's what happens. So you should never put a bigger fuse than what it calls for. There's a reason for it.
It's incredible, no?
Yeah, because what happens is you short the system out. The wires are very small in the harnesses, and there's too much draw, too much power. It'll burn up the wires, and once it burns up one wire, it'll start burning all the other ones. It'll catch on fire, and just like you see in that video, you see.
Oh,
It's catastrophic.
yeah, it's catastrophic.
Alright, this is the situation with the harness. My friends, remember, in our inboard engines, gas and diesel inboard, you remember, immediately the engine start, the engine need produce your own power, your own electricity. If not, the engine stop. What is the element that immediately the engine start produce the electricity? In inboard engines is the alternators. Yes, you remember the alternator produce output power. What is the color of that cable? Orange. Exactly, the orange cable. That current coming out through the alternator goes into the run relay. You remember in the chapter 15 of our electrical class, the episode related with the creation of the harness. That episode, correct. In that episode, I explained how the harness is created and how the alternator is part of the harness. Yes, the output power from the alternator enter into the run relay in the position 85 or 86, one of these, in order to keep the relay closed, and the power, purple color, enter into the solenoid or idle valve and into the fuel pressure pump. Alright, this is important. If the engine not produce your own power, the engine stops suddenly. In outboards, the engines produce on the flywheel with that coil, the outboard produce AC power. And that AC power after that is rectified into DC. There are different forms. Some engines have a special rectifier to convert in DC, and after that, that current feed the harness and the computer. In other engines, that current AC enter in the computer and is converted into DC. How is that conversion, Mr. Rodriguez?
Danny, how can you get 55 volts on the injector?
Alright, so the 55 volts comes from the stator. There's a two-part of the stator. So basically it's like having two stators in one. And what happens is the engine actually has a capacitor, which I'll show you. But how this works is if you come here,
That's the flywheel.
that's the flywheel. As this rotates, it generates AC current.
AC power.
AC
power, correct.
And then from the AC power, it's going to the computer, which converts it into DC by using a
The
regulator.
rectifier is in the computer.
Correct. And then once it does that, there's a capacitor
When the current is rectified, enter in the capacitor
in its storage.
and storage. When the capacitor is full charged, the capacitor,
Discharges it and sends it to the system.
Correct.
And that's how you maintain your 55
and you
volts.
check this capacitor exactly the same like in other videos we checked.
Absolutely.
All right, the same procedure. We discharge the capacitor.
Absolutely. Same
All right,
procedure.
nice. What is the capacity? That capacitor is 50,000 microfarads. 50,000 microfarads are 50 volts.
Correct.
Correct. Okay. The procedure is exactly the same like we use in other episodes to check the capacitor. Normally, when the capacitor is damaged, is
It swells up.
Yeah.
And these, what we see a lot of is what happens is because when it's actually installed in the motor, it's upside down. Sometimes the seal
It's
go
leaking.
bad and it'll leak out.
It's leaking.
And you'll see when you pull the boot out, you'll see actually the oil in there.
And this is poison.
Yeah, it's
Yeah.
poisonous.
Okay, this is the situation with the computer and the AC power produced on the flywheel. Remember, my friends, in outboards, the engine is vertical. The crankshaft is vertical. And on top of the crankshaft, you have the flywheel. Exactly like this. The flywheel enter over there on top, and in front is the crankshaft sensor. In front of the flywheel is the crankshaft sensor. Yes, that's the flywheel. And the flywheel internally have the coil to produce the AC power. Be careful, there are two types of coils. What are those type of coils, Mr. Rodriguez? Danny, in this particular engine on the flywheel, the AC power is produced. There are two types of production of AC power, with coils and with magnets.
Correct. And this one has the magnet. This is the new style that has a smaller magnet, and then here's the old traditional style.
With
These are repairable. These are not. These are once the magnets go bad, because what happens is they come loose like this, and once they come loose, they get jammed into the coil and damage the coil, and then that's it. See how it sticks?
Correct. Yeah.
So this is the old style and the new style.
You
Now,
can replace those magnets.
Yes, you can replace these, but you have to be careful. There's an inner magnet inside here. If it spins out, you can't repair it. The flywheel's done.
Correct. In other words, if you replace those magnets, you need to be careful with the polarity, because this one should be positive, negative, positive, negative, positive, negative. If you replace this one for a negative, you change the timing order.
Correct.
Okay, my friends, right now it's clear how the harness is protected and how the power is produced, AC power in this particular case. And now we are going to check how is the distribution of the current into the harness and the computer and how the system works.
Okay guys, we are going to continue with the ignition system in the E-Tech engine. In the previous episode, Professor Danny explained how the injector works with the spark plug together and the position of the spark plug in relation with the position of the injector, how the fuel enters in the system, how the fuel is injected through the injectors, and now we are going to try to understand how is the ignition system.
Okay, so the ignition system works like this. You have the harness that goes from the motor to the console, which lights up your gauges and your ignition switch. And you have his main 10 amp breaker. That's the same thing like we saw on the Merc Cruiser, but it's in a 10 amp. It's that one. So if this breaker's broken or bad, you're not going to get any power. Trim and till, you're not going to get anything. It'd be like almost like a dead motor.
Only 10 amps?
Only 10 amps.
It's nothing, no?
It's nothing.
For the harness?
For the whole harness, yeah, it's only 10 amps.
And the injector with the 55 volts?
With 55 volts. Now that's a different system. It still won't pop this. It'll fail. It'll give you a code and put you in safe mode. The thing is with the ignition system on this, that the engine recognizes any faults, it's going to bring your RPMs down to put you in safe mode so it won't blow it up.
Okay. All right. The first step is check the fuse.
Check the fuse.
All right.
So when you check the fuse, you got power through the fuse, then you know you have power to the system.
On the system.
Okay?
All right.
But it's important that you make sure that it's not blown.
Yeah, remove the fuse and verify the fuse.
And then you can take
and
your
check continuity
between the two.
Perfect.
Okay? And then you also want to make sure you have power coming from one side.
Yeah.
Okay?
Yeah.
So where this power comes from is from the battery cable that comes from the battery
and back to the other one. Yeah.
And back to that one.
Correct. Danny, of course, this cable continue over there and bring the power to the computer.
Which it has to have a minimum of 9.5 volts in order for it to stay running.
All right. Okay. Minimum 9.5 on the computer, and the computer starts with the distribution of current.
And how it does that? It has a crank position sensor, has a map sensor. It also has a atmospheric temperature. It has an exhaust pressure sensor. Has all those sensors, so it calculates everything that it knows in order for it to give you the right amount of fuel.
All right. In order to send the signal to the injectors to open, because you explained before that each injector have your own number.
Yes, no? It's programmed. So that way, when it needs injector number 1 or 2 to fire, it knows that, hey, serial number X injector controls that cylinder. We're going to tell it how much fuel it needs.
Okay, for that reason, the diagram that we have on top in this moment is critical, no?
Correct.
Because each pin of this injector is over there. You need follow the diagram. It's simple.
Absolutely.
The procedure.
And I'll show you on the motor where it hooks up to the computer where those pins are at.
Correct. Yeah. You remove the harness here and you verify the pins.
Correct.
Yeah. According
check
with
the continuity according to the diagram. You would check continuities from here. Let's just say to this injector. You would find out which one it is. Hook it up to here and to here to know if you have a continuity. And you also have to check to a short for ground.
Correct. This is for the injectors.
Right.
And for the spark plug.
Spark plugs, no. The spark plug, well, you have the ignition coil.
Correct.
Okay, so the wires that feed the ignition coil will serve the same purpose.
It is here also.
Correct.
Yeah. Okay, perfect. Yeah, you have a spark, you have fuel, and the engine starts.
Correct.
Right. Of course, if the parameters on the camshaft, oxygen sensors are okay.
Right.
No. This is what is the most common complaint in relation with ignition in this type of engines?
The biggest complaint was a couple things. Okay. Also, what will affect your ignition is if you have it's called the shift interrupt switch.
What is this, Danny?
This is actually what the shift actuator is. This is what shifts the engine. So if you took the bolts out and you popped it off.
Oh, wonderful. This is a solenoid.
It's a solenoid.
And look at this. This can enter.
If you look into the rod.
Enter into the rod. The top of the rod have a groove, no?
Yes, it has it's an octagon. So if you look here,
enter over there. Enter over there. And this one goes up and down,
Correct.
Up and down. It's a solenoid.
And it's dry. If you notice, there's a seal on the bottom, and this is sealed off, so no water gets into it.
No water.
Or oil.
Or not, yeah, of course. For that reason, they have a label and say, do not fill with oil.
Correct.
If not, you damage
the unit because you have the circuit board
Oh,
controls
of
as well.
course. Look at the circuit board of the unit. This is a perfect solenoid.
Yep.
And it's controlled by the computer.
Computer and the control
and the
box.
shift control.
Yeah.
Okay.
See, on the
perfect.
system that controls all the electrical, there's two systems. You have two NEMA networks. You have a private network and a public network. The private network controls all the engine information, and the public network is basically the standard NEMA system.
The NEMA system. All right. Perfect. And that's the seal to avoid that the humidity and
water gets in
oil
there.
enter over there. This one should be completely dry.
Completely
Only a little lubrication here.
Yeah, just a little bit of grease only for the rod, and then there's a special tool that we measure the height according to the specs of the manufacturer.
Exactly, because this one should be. Yeah.
This is standard set, and then that one is the one where you make the adjustment.
Oh, wonderful.
And how that works is you have a pin that goes through, and it moves the clutch dog for you.
Correct. In other words, in this particular engine, E-Tech, we have the drive
Electric
shaft
Yep.
electronic.
Electronic shift.
It's not mechanical.
Not mechanical.
Wonderful. Glenn, can you explain why this element is too sensitive in terms of calibration?
Well, this is set, and the calibration will be on the inside.
On the inside, yeah. All right.
And it's got to be
It's a bolt that you calibrate up and down.
correct.
Over there. Right.
Inside.
Like the picture that you have on the screen.
Correct.
And you turn it down or up. And what happens if the calibration is not in the point recommended?
Well, it moves what we call a clutch dog, and if it's not adjusted properly,
Correct.
as it's just running, like if it's running in neutral, the gears might be just touching, and then it makes a noise, and then metal, and then you blow the
Or
dog.
it's difficult when you engage the gear, you hear the click.
Yeah, you get slamming in. Right, you move it just a little bit of being gear, then reverse. You got to go way back.
Correct.
So you got to bring that in the middle.
And this one should be calibrated with this bolt, the bolt that you have on
With
the
that
screen
bolt on
on
there.
top.
Yeah.
Okay, perfect. That bolt should be calibrated up and down,
Up and down.
up and down. Or
There's a gauge you set on top of this.
yeah, uh-huh.
And then you know if you got it right.
Yeah.
If not, you take it out again, adjust again.
Of course, you need to remove the lower unit
Right.
to calibrate that.
Oh yeah.
Yeah. If you run the engine for a long period of time and properly calibrated, you can damage the lower unit.
Oh yeah, definitely the gears. I mean, because they'd be grinding against one another.
Uh-huh.
When you got to put it in gear or out of gear.
Correct.
It's just what you're doing. If it's out of calibration, they're just about touching, and then it just wearing the gear, metal in the oil.
Correct. In that case, if you take a sample of the oil of the lower unit and you analyze that sample, you found that too much chromium, too much iron levels.
Correct.
Because the metals are.
You see the little metal chips floating in the oil.
Correct. Exactly. If you expose the oil in a napkins, you see the metals.
Yeah. On the drain, when you drain the gear oil,
Correct.
it has like a little magnet.
Yeah,
on
and
the
the
end of
magnet is-
And then you see the metal right on that.
Correct. On the magnet.
And you know you got something wrong. The
Yeah.
bearing, shim,
Chims.
this ain't adjusted properly.
Correct. Because this engine is fully electronic, it's controlled by the computer, fuel system, lubrication system. All the systems are controlled by the computer. That calibration is controlled on the computer?
You can't control the calibration,
Uh-huh.
but it will tell you the calibration.
Oh.
So if it's out of calibration, a code will come up and it will say something.
And you have a check engine light.
check engine light.
When you connect the scanner, immediately you have that code related with the calibration.
Most of the time, if you've been using the boat and it's reading normal, everything's fine, and then the light comes on, you have a problem other than calibration.
Yeah. Oh, this is exclusive for this type of engine, for the E-Tech.
At least it tells you that you have something wrong. Get it fixed before you run into more damage, more money.
And what that does is allow it to engage and disengage.
That's the
in gear.
neutral safety
The
switch.
Well, no, neutral safety switch is in the control box.
yeah.
The shift interrupt switch works. It kills the engine for a split second to allow the gears to engage and disengage.
Yeah, correct.
And if that's holding too long, it'll affect your ignition. It'll knock out one bank of the engine. So you have to pay attention when. That's why it's important you do spark check. If you only have spark on one side, more than likely the probability is that you have a problem with the shifting.
Danny, excuse me, can you repeat to the student that situation is common, that situation?
Okay, absolutely. So let me give you an example. Your customer comes in, the engine won't run. So first thing you do is you do compression and spark check, and you check. You notice that only one side of the engine has spark and the other side doesn't. So you have to think, and obviously from experience and reading the service manual, you realize that the shift interrupt, what it does is it kills one bank just for a slight second to allow the gears to engage and disengage in the lower unit, so you don't have that big bang. And if it holds it too long, obviously the engine can't stay running because it just kills it for a split second.
Correct. Oh, that's incredible. That's the most common.
That's actually one of the most common, because what happens is, corrosion sets in the bushings and it stiffens up, so it doesn't release it quick enough.
Correct. Other typical question is about misfiring. No?
And misfiring, yeah. Well, in misfire, so let's say you have a bad injector, it'll give you a misfire,
or a
bad spark plug, bad wire, maybe one of the wires from the computer to the injector is either chafed and is grounded out. You have to know. That's why it's important to have a service manual.
And then once again, exactly, the service manual and the wiring diagram. If you have the wiring diagram, you can follow each pin according with each injector, and each pin according with each sensor, and each pin according with each spark plug.
Absolutely.
That's not complicated.
No.
It's identify what is the cylinder with the problem. Okay, it's cylinder number 2. Okay, let me check the cables for that injector. I identify where are the cables. I check continuity on the wires. And after that, I check with my multimeter if I have the output here recommended for that element.
Absolutely.
Correct. That's simple.
That's it.
And it's exactly the same for the coil of the spark plug. Right. This is the typical troubleshoot for ignition system.
I want to explain something in relation with the timing adjustment. In the previous episodes, I explained the timing adjustment for inboard engines. And you remember that I explained that in inboard engines there are ignition systems. The old version, they use on the distributor points and condenser, like the distributor that you have on the screen. Those distributors open and close the points according with the cam. And each time that the points open and close, interrupt the ground. In order to start the engine properly, you need adjust the timing for idle. The procedure that I explained before for timing adjustment with the timing light, this is for idle. But when the engine accelerates, when the RPMs increase and when the load increase, the engine itself adjusts the timing, advance or retard. I never mentioned that before because that calibration of the timing according with the RPM and the load when the engine is running create confusion. For that reason, I never mentioned that. I only explain the procedure to do the timing adjustment calibration in idle. In the new engines with computer, with ECM and fully electronics, those engines adjust the timing automatically in the system, the computer. It's not mechanical. You don't need to think about the timing for wide open throttle because the computer calibrates the timing by itself. Exactly the same for outboards. How the engine inboard with the electromechanical system calibrate the time for wide open throttle and heavy loads is with counterweights located in the distributor. Those counterweights, according with the RPMs, open and close and advance or retard the timing according with a vacuum valve on the side of the distributor. That vacuum valve for timing adjustment. This is in all versions. I never mention that because every day are less popular and I create confusion for yours. Alright, the majority of the engines today, all the engines, they adjust the timing according with the RPMs and the load automatically in the computer, in the system. You don't need calibrate that situation. In outboards, it's the same. Doesn't matter if the engine is 2-stroke or 4 strokes. The engine automatically, the computer calibrate the time and advance or retard the time depending of the load and depending of the RPMs, according with information coming from sensors, oxygen sensors, throttle position sensors, crank position sensor, cam position sensors, NOx sensor. Those sensors send information to the computer, and the computer understands if the engine is low, underload, overload, and according with that, send the information to the throttle position sensor to adjust the RPMs, and adjust the RPMs and allow more or less air in the combustion chamber. That's the most important part. Yes, that situation is controlled by the ECM, by the computer, and you don't need to think in that calibration. However, there are older versions of gasoline outboards that they have a mechanical system, electromechanical systems, and the calibration of the timing is with a mechanical system and a mechanical link that I am going to explain right now. But in general terms, the position of the timing position in idle is basically the same used in previous episode for inboard engines. Yes, you use the timing light, you start the engine, and you point it where the mark on the flywheel is located, and according with the timing light, you calibrate the timing in idle, when the engine in idle. Yes, normally you have the marks on the flywheel, and this is the 0 position, and you have a retard and you have a advance. You have retard and advance, both of them, and you calibrate the position of the flywheel according with the mark, this mark located on the side of the block in front of the flywheel. And this is the mechanism, and I explained that procedure exactly the same with respect to the spark plug number 1 and the piston number 1 in the top dead center, exactly the same like we did in inboard gasoline engine. Alright, this is the calibration in idle. In wide open throttle, the engine calibrate the time, advance or retard, automatically if the engine is fully electronic with a direct fuel injection or indirect fuel injection. If the system is electronic with computer, the computer calibrate automatically the time more or less, advance or retard. Alright? If the engine is mechanical with the carburetors and electromechanical injection system, you have a link. To adjust the throttle, and the bracket have a special connector in order to advance or retard this element. The trigger timer base, and you advance or retard the trigger timer base according with this procedure.
Danny, I know that the new engines, the new modern engines, electronic, they don't need adjust the timing because the computer is intelligent and adjust the timing.
Correct.
But in older engines like this, carbureted with mechanical system, the timing adjustment is important.
Absolutely.
How is the procedure to calibrate the timing here?
Well, just like we saw in the previous videos, you have to make sure that all the flaps are closed.
Correct.
Okay, and then you have a cam that goes in here. So when you advance the throttle, there's a rod that moves there, that moves this, and this is what advances your timing.
Ah, you advance over there or retard.
This is what advances the timing and retards. So at a certain RPMs, at low RPMs, it'll tell you, let's say 4 degrees, and then at wide open throttle, if you see here, it tells you 26 degrees before
26.
top center.
This is the recommended by the manufacturer.
Manufacturer, correct.
All right. And how is the movement?
The movement with the throttle is like this.
Okay,
And
and
again, there's a cam that goes in here with a rod that goes from here to here. You see the opening?
the rod that we have on the screen right now.
So when you move this, that moves.
That one, yeah, perfect. That one moves exactly at the same time. Oh, perfect.
And what they call that is when they call it in this industry when they do it, it's called a sync and link. It's called a sync and link. It's called a sync and link.
Okay, and the tool and the element that connects this with this that is on the screen right now is adjustable, no?
Yes, there usually is a little rod that you can adjust.
Okay, perfect. And in what scenario, in what case you need adjust that link?
Only if the timing's off. If someone really that's set by factory, it's never really messed with unless some mechanics mess with it, and then you have to redo
Oh,
it.
that's very important.
And
And
they normally have a wax. Like here, they'll put a wax on it so that you know if someone's tampering with it.
and what is the symptom when the time is a little out?
Well, you'll have a sneezing. Basically, when the engine will be running, and then all of a sudden it'll start sneezing on you. It's running lean.
Okay.
And then if it's running rich, obviously it's gonna.
Or in some cases is a hard start.
Absolutely hard.
That's the most common.
And you won't get full throttle advance if the timing's off.
Okay, perfect. Thank you.